In our last unit, Unit 3, we learned to track the motion of all sorts of objects. Here's the thing though, we just tracked one object at a time, and let's be honest, one object is a little boring. What you want to see is two objects smash into each other, like say when monster trucks crush a car, or when a nuclear bomb strikes an asteroid, as occurs in many of my favorite sci-fi movies. These things are called collisions, things running into each other. That's what we're going to study in this unit. We're going to begin by looking at something called momentum and impulse, and we'll build on those ideas to understand all sorts of collisions. Let's smash this lesson. Recently, we've been thinking about the motion of objects down inclined planes, like this skier. We've calculated friction and gravitational acceleration when we have just one object. But things aren't always so smooth. Sometimes we have abrupt changes in our motion, usually as a result of a collision. And this is what we are going to study in detail in this unit. Not one thing in motion, but two. Like an axe colliding with a target, or a child colliding with the surface of a trampoline. We'll learn how to think carefully about the transfer of energies and how to calculate the velocity of objects before and after they collide. Let's review our lesson objectives for this introduction to Unit 4. First, we'll introduce momentum, which is a very important property if we want to understand collisions. The transfer of momentum is called impulse, and so next we'll introduce impulse. Lastly, we'll categorize collisions by introducing elastic and inelastic collisions. All right, first up, momentum. What's momentum? Momentum is the tendency of an object to stay in motion. What does that mean? Well, some objects have enormous momentum. This guy is called a container ship, and it has a very large mass and a very large momentum. It'll take a lot to change its motion. Some objects, though, have very little momentum, like these butterflies. Imagine, for example, that one of the butterflies runs into the shipping container. It's not even going to care. Momentum can be calculated as mass times velocity, so that P there turns out to stand for momentum, the M for mass, and the V for velocity. We'll cover this in much more detail in a future video. The thing you should know about momentum is that it's conserved. Momentum is conserved. That means that it's not created and it's not destroyed. That gives us a very important mathematical tool to solve problems. The conservation of momentum mathematically says P final, that's momentum final, is equal to P initial, that's momentum initial. So whenever we look at a collision, we can always know that the momentum at the beginning and end is exactly the same. For example, at the start of a pool game, we have the break. The white cue ball is launched at the collection of pool balls at the far end of the table. And the faster that cue ball moves, the greater chance there is that we'll sink one of these other pool balls. This is conservation of momentum in action. The pool balls only have the momentum to work with that we gave them in the beginning. Now, when we transfer momentum, that's called impulse. And this is the change in momentum of an object during a collision. Whew, that's a lot. So basically, what we're thinking about there is something increasing in momentum or decreasing in momentum as a result of a collision. We can calculate momentum with this wacky looking equation. The first thing you'll notice are the triangles. Remember, that's the Greek letter delta, it means change. So this says that the change in momentum is equal to the force times the change in time. And this idea of impulse helps us understand how much energy is transferred during a collision. That's why a kick, for example, is so powerful. Or take a golf swing. The amount of energy transferred from the club to the ball can be understood again by impulse. Maybe you've heard that on a golf swing you're supposed to follow through. That's because that increases the time the golf club and the ball are in contact. Now, here's the thing. Collisions ultimately come in two forms. When things collide, either they bounce back or they don't. Like an axe doesn't bounce back. This contrasts with a racquetball. Here, the racquetball is launched at the surface and it bounces over and over again. And we have special names for each type of these collisions. Elastic collisions are like the racquetball, And here we want to ask, did the objects bounce? If they did, those are elastic collisions. Inelastic collisions are like the axe throwing. There, things stick together. So that's the question we should ask. Did the objects stick together? All right, so that's an overview of our unit. What did we learn? We introduced momentum, which we said was the tendency of an object to stay in motion. When momentum is transferred, we call that impulse, and so we introduced impulse, which depends on the force and the amount of time those forces are in contact. Lastly, we introduced elastic and inelastic collisions. Elastic collisions are where things bounce, and inelastic collisions are where things stick together.
Hey, hey.